This last example comes directly from the free response section of the 2016 AP exam. So the figure shows on the right here, this is a graph of f, and it's defined from -4 to +12 inclusive. So it's a closed interval. And we have another function g, which is not shown, and g is the area underneath this curve from 2 to x. Okay, so starting at 2 and some point x. So we can go to the right, and the area above would be positive, and the area below negative. If we go to the left, this area becomes negative, and the area below becomes positive. So that's important to remember because this is our reference point. This is our starting point. Integrating this way, we get the positive values. Integrating backwards, we go in the opposite direction, so we're going to have it opposite. So it's going to be negative. Up above is negative, below is positive. Okay, so that's one thing to just establish at the beginning. And it says here, does G have a relative minimum, maximum, or neither at x equals 10? Okay, so what's happening? So the f value is equal to 0. Okay, so that's possibly a max or a min. But to do that, we really should test the slopes. So at x equals 10, we have a slope of 0. So that's our f prime, or we'll call it g prime. Okay, so our g prime value is equal to 0. Okay, so that's what we're going to look for. We're going to look for where g is equal to 0. On the left-hand side, the g prime value is negative, so it's going down. So although the slope here is positive, okay, that's not what we're looking for. We're not looking for a positive slope. We're looking for y values, which represents the slope, which is g prime. So f and g prime are the same thing. So it bottoms out like that, and it looks like if it goes up, that'll be a minimum. But on the left-hand side of that, we have negative y coordinates. So it's going to keep on going down. Okay, so the slope, this means that f is negative, which means g prime is negative, which means the slope on g is negative. So this is going to be neither min or max, so neither. Okay, so then looking at the next question, does the graph have a point of inflection at x equals 4? At x equals 4, that's our g prime value. So that means that, well, it doesn't have a 0 slope here because the slope is undefined. So if I want the second derivative at 4 is undefined. Okay, so we have no value there because the slope at that point is undefined. However, if I take a look at my concavity chart, so really I'm looking at my g double prime, and at x equals 4, it is a point of interest because it is undefined there. And if I take a look at the g double prime, that really is the slope of the g prime graph, or the slope of the f graph. And the slope of the f graph here is sloping positive. If the slope is positive, that means it's concave up, okay, on the original g graph. On this side, the f graph has a slope that's negative, or in other words, it's the derivative of f is negative, or the second derivative of g is negative, so that means that the second derivative being negative is going to be concave down. So it is defined at that point. The actual value is defined because although the second derivative is not defined, the value of g is defined, and it's going to change concavity. So yes, it is an inflection point because changes concavity. So it changes concavity across x equals 4.